So we've got 4 distinct areas in the Amazon basin, and they're largely defined by the relief that's there. So on the western side, we've got the second tallest mountains in the world, the Andes Mountains, and they rise up to about 6,000 metres high. They're still growing. They're made by volcanic processes as the Nazca Plate subducts under the South America Plate. So they're quite young, quite soft and easily eroded mountains. They'd be much higher, of course, except we have a whole lot of glacial and fluvial or river erosion wearing them down. In the northern part of South America, there's an ancient landmass. It's actually a remnant of Gondwana land, which is before the continents shifted to the position that they're in now. There used to be a big supercontinent in the southern hemisphere called Gondwana land. The northern one was Laurasia. But this is ancient rock, and as I've drawn it on my diagram, I've used these little flat top mountains rather than the pointy mountains of the Andes, because these are very old and worn down pieces of rock. We've got the Guyana Plateau about 2,000 metres high in the north, and we kind of have a matching plateau in the south, the Brazilian Plateau. That's also 2,000 metres high, and it's also an ancient remnant or leftover piece of that landmass called Gondwana land. So around the edge, you've got these very high mountains, and then in the centre, you've got this very flat lowland area. It's only about 10 metres above sea level, and it's made up of sediment that's been washed down from the other mountains. So that's the Amazon basin itself, is the large flat area in the centre. Okay, moving on, we've got the vegetation, and the vegetation kind of matches those areas of relief as well. On the Andes Mountains, we have montane forest. It's a word that sounds like mountain, and if you've been up mountains, you've probably noticed that the vegetation changes as you gain altitude. The trees themselves get smaller as you go up, and they get thinner, so there's less of them as you go to the top of the mountain. Eventually, you get to the snow line, and there's no vegetation at all. And we also have different types of plants that are suited to mountain conditions. So things like alpine mosses and flowers, usually ground-hugging plants that manage to exist in those very cold environments. In the centre of South America, we've got the Amazon basin, and of course that's famous for being the largest area of stratified tropical rainforest. We're going to learn that the tropical rainforest has layers inside it, but in the basin we find tropical rainforest. In the Guyana and the Brazilian plateaus, though, the conditions are quite different, and rather than having thick vegetation like the basin, these are areas of grassland or savanna. And in Portuguese, because Brazil speaks Portuguese, they have their own word for it, which we're going to learn, and it's called cerrado, C-E-R-R-A-D-O. So it's a very dry environment. A lot of cowboy movies were made back in the day in these areas. It's quite different from the lush tropical rainforest we'd expect in the centre. Okay, on to the climate. With climate, the temperature remains largely the same because this area is located close to the equator, and we talked about that in class being like 26 degrees Celsius on average. It does get a bit cooler in the night, a bit warmer in the day, but essentially it's a very stable temperature. So it's mainly the rainfall where we see the differences. This time we'll start in the centre. So in the Amazon basin, the main type of rainfall that occurs is convectional rainfall. And convectional rainfall, if you remember from year 11 geography, convection currents is when the magma rises up due to the heat from the core. Convectional rainfall is when moisture rises up due to the warmth of the sun. We experience it in New Zealand in summer as well. We have quite heavy downpours and sort of tropical storms in the summer. As the ground heats up, forces all that moisture to rise, then it condenses into thunderclouds and comes crashing down again. So in the Amazon basin, the water's going up and down through convectional rainfall. A lot of transpiration, which is like the plants breathing out moisture. About a third of the rainfall that falls down is sent straight back through transpiration, very misty and cloudy. In the Guyana Plateau and the Brazilian Plateau, we have orographic rainfall. So this is when moist air is blown by the wind, and it comes from a source. In this case, it'll be the Atlantic Ocean, And as those easterly winds bring the moist air from the Atlantic Ocean, they make it rain on the ocean side of the plateaus, and that means it's dry as the wind goes inland. In New Zealand, our wind goes from west to east. It comes from Australia, but in the Amazon basin, it's going the other way. It's coming off the ocean and causing orographic rainfall on the eastern side of those plateaus. In the Andes Mountains, they're obviously a massive barrier. They've got an alpine climate, so we've got to recognise that these are very tall mountains. So at the top, we're going to see snow and ice and glaciers, but they also get orographic rainfall as well. So a lot of moisture gets released on the eastern side, and it leads to very dry areas on the western side. We've got places like the Atacama Desert, where the Nazca lines are. Okay, looking at soil. You probably don't know much about soil. You kind of take it for granted. They reckon it's New Zealand's biggest asset, but there's actually different flavours of soil. Easiest place to start is the Andes Mountains, because in mountain areas we have very thin, sometimes no soil at all, due to the steep terrain. So the harsh conditions at the top, the high rainfall from the orographic rainfall, makes it very difficult for soils to develop. Soils are like broken down bits of rock mixed with organic material. So in these alpine areas, a lot of that stuff just gets stripped off the land and taken by rivers to be deposited. So of course, in our case, a lot of that material is deposited in the Amazon basin. So they've got very deep soils, up to 40 metres deep, but remember that this is quite a flat area close to sea level anyway. And the main type of soil they have is Latisol soil, Latosol. And it's made, they've also got alluvium beside the rivers, so that's the mud that's brought down by the rivers. So the soil has been laid down in these big layers. We're going to learn a bit about Latisol soil and how that works, but ironically, it's not actually very good soil, despite the fact that on top we've got this lush vegetation. The type of soil that we find in the plateaus is not very good either. You can see in this picture over here, very rich and red. It's got a lot of iron in it, and iron, as you might know, rusts in the rain. So soil that has a lot of iron turns red as well. So these are called podzol soils, Podzol, and they've suffered heavy leaching. Because this place gets so much rain, the rain flushes out the good stuff in the soil. And if there's no vegetation on top, that's going to lead to sort of long-term infertility. Last thing we'll mention is the rivers. You think rivers are just rivers, but no, there's different types. In the Andes Mountains, we have whitewater rivers. Some people think this is because it's got waterfalls and rapids, which it certainly does. But when we're talking about whitewater rivers, we're meaning they're milky because they've got lots of suspended sediment, lots of worn down bits of rock that's floating in the river. And so those rivers appear like cloudy. In the northern plateau, the Guyana Plateau, we actually have blackwater rivers. So we talked about that in class. By Manaus, we have that famous tourist attraction of the meeting of the waters, where the tourists try and see the waters mixing, but it takes like 20 k's for it to happen. So the rain hits the Guyana Plateau, trickles down to the base, and then it has to go through this swamp area, which means the rivers go black. In the Brazilian Plateau in the south, the water comes off the plateau, and because they're so ancient, these rocks and mountains, they can't actually be worn down much at all. So the water coming off the plateau itself just is clear. And because there's no swamp for it to go through at the base, these rivers all meet the Amazon River down the centre as clear water tributaries. Clear water sounds really nice, but it's not actually that good for living beside, because there's not many fish, there's not much nutrients in the water, so there's not much life in the water. So we have a few different coloured rivers, and then they all mix in the centre. So the Amazon River is that chocolatey colour because all the other tributaries, all the small rivers have joined it, and it's all churned up. It's very turbid or cloudy. And the main thing about the Amazon River, it's very sluggish and slow because it's such flat land. So it's a meandering river with twists and turns, quite different from a lot of New Zealand rivers. So that's a lot of information. Good luck putting that together.